After manually defining those clumped together areas, we can move on to generating some procedural ones. Now we don't want these procedurally generated clumps to be scattered where we've defined those manual ones, so I'm going to start by deleting out those manual sections. I'll just drop in a blast, and in the group I'll type @clump is greater than 0, and that'll be a point group because clump is a point attribute, and we'll connect that to our blast non-clumped, which is what we were using to cut out that hole in the building. Now we're going to generate the procedural ones by scattering some spheres on this geometry here, and in order to scatter onto that geometry we'll need to unpack it, and then you can drop in a scatter sop, connect our unpack to that, and you can play around with how many clusters are generated. In my case I think I generated about 70 or so, and you can play around with the seed if you'd like. And sometimes I like tweaking the relax iterations as well, but we can't really art direct this very well when we're just viewing the points here. So let's go ahead and scatter some spheres onto those points. So I'll drop in a sphere and set the primitive type to polygon, and maybe turn the frequency up to about 5 so that we have some more resolution on there. And we'll use a regular copy to points to copy the sphere onto our scattered points. So the sphere in the left input, points in the right, and these spheres are all the same size right now, so let's vary up the scale on those. I'm going to randomize the P scale. If you want to, you could also randomize a scale vector to non-uniformly scale them, but in this case I'm just doing a P scale because we'll be distorting them afterwards. And we'll set the dimensions to 1 because that's a regular float attribute. And you can see that it's already randomizing our sizes from 0 to 1. But those tiny spheres are much too small, so let's change the range. In my case I'm using 0.8 to 1.4. Now at this point it's helpful to template display our building geometry so that we can see the sizes and shapes of those clusters relative to our actual asset. And we don't want to keep these as regular spheres. We'll want to distort those shapes, and I like using an attribute noise for this. So we can connect that attribute noise to our copy to points output, and we're going to set the attribute to P instead of that default of CD. And this additive mode is correct because we just want to add some noise to our current point positions on the spheres. And right now you'll see the whole sphere seems to be shifting in more or less one direction. And that's because our default noise is just going to be from 0 to 1. And if you turn on this center noise option, that will fit your noise between -1 and 1, so it doesn't really push your spheres all in one direction. It's a bit more genuinely random and even in all the dimensions. And you can play around with the various settings on the attribute noise to art direct the sizes and shapes of these clusters. I'm going to go with a significantly bigger element size, a little over 7, and we'll need more amplitude as well. And this looks like a decent starting point for our clustering. And if you want to experiment with different variations on your cluster distribution, you can go back to the scatter sop and change that global seed. So perhaps there's an area that you want to see more or less of that clustering happening, and you can play around with this until you get just the distribution that you like. And one little word of warning on the cluster patterns. I found that if I was too aggressive with this and used too many and too large of these clustered sections, that it could interfere with the collisions with the creature. Now we're going to use infinite strength for all of these clustered together clumps, and with too many areas infinitely strong in their constraint strength, that could cause some of those pieces to pass through our creature collider, which we definitely don't want. At this point, I would avoid being too picky about the exact shapes and distribution of these clusters because we can't really see exactly which pieces are being stuck together. We can have some idea from these distorted spheres, But these spheres are really just going to group all of these pieces based on their centroids, so the exact clumped together geometry will differ from what we see here. So we're going to apply all of these clusters in a loop and then transfer that data onto the geometry, and then we'll be able to see exactly what these clusters look like.